So this first question is just a definition. As the sample size n increases, the shape of the distribution of sample means taken with replacement from a population with mean mu, standard deviation sigma, will approach a normal distribution. This distribution will have a mean of mu and a standard deviation changes, sigma over the square root of n, and this is literally a statement of the central limit theorem. I'll explain the central limit theorem if you aren't sure how that thing works, right? So let's say this box represents all CUNY students, right? All CUNY students in here. And I mean, maybe like these little circles, I'll make them dots because it's hard to draw still a lot of circles. Maybe all these dots represent CUNY students, right? These are all different CUNY students here. I think there's about 300,000 CUNY students. So all 300,000 CUNY students are in this box, right? And let's say we're measuring the number of hours of sleep per night. No, let's say the number of hours of studying per week. We can get more variation on that. Numbers of hours of studying per week, right? During this pandemic, this remote learning period that we're going through. So this population, right? The mean of this population is mu, and the standard deviation of this population is sigma. Now, this population doesn't have to be normally distributed. I don't care if it's normally distributed or not. In fact, let's say it's not normally distributed, right? Let's say this population is not normal. It doesn't form a bell curve, that distribution of these numbers of hours of study per week. So, as I take samples from this population, right? As I take a sample here and a sample here, and my samples are taken with replacement, so I can take the same student in a sample, right? But my samples all are of the same size. So my sample might be 1,000 students. Each sample might be 1,000 students, right? N equals 1,000. For each of these samples, right? If I take the mean, the average number of hours studying per week, if I take the average of each of these samples, all right, the shape of that distribution of the sample means, the means of the sample, if I graph the histogram, it would approach a normal distribution as this n gets larger and larger. Let's say I started at n equals 10. Each sample is 10 students. And then I went to 100, and I went to 1,000, then I went to 10,000, etc., etc., etc. I could have used smaller increments, right? But whatever. As n gets larger and larger and larger, the distribution of these means of each of these samples will approach a normal distribution. Sounds kind of counterintuitive, but that's what the central limit theorem says. And the distribution, that distribution of all those sample means, the mean is going to approximate the mean of the population, and the standard deviation is going to be the sigma over the square root of n. This is also called the standard error of the mean. That's the central limit theorem.